Right, I'm going to do an experiment. Now I've tried this as I showed you with the fan on, and I don't think the fan is pulling enough heat, because this hot side here, the bigger heat sink, well really there's 4 heat sinks glued together there, 20 by 20, isn't it? No, 40 by 40 I mean, sorry. That's getting hot. This side is getting chilled but not very cold. So what I intend to do is use some water in this sort of tin lid tray. Might have to get some more actually. Yep, I'll get another cupful. And that's going to act as a coolant to take away heat from this hot side, hopefully anyway. I'll just get some more water. Right, I filled it full of water. I had to put some rulers under this edge because it was very slanty. It's still slanty a bit because it's shallower at that end than this end. Let's move this over this way. Let's turn it on the power. I'm going to give this a few minutes to stabilise temperatures. I don't think it takes too long actually. So here I'm hoping that this water will take away the heat. If not, the tin lid itself might help take away the heat. And then, because it's taking away the heat, it'll cause the cool side. Oh yeah, that's getting cold. The warm side, nothing. I can't feel anything really. So it must be about ambient temperature. So I'll give it a bit longer and then I'm going to use this on it. One way to find out is if it's getting really cold is put some drops of water on here and see if they freeze. Oh yeah, that's getting pretty cold now when it feels it to the touch. So let's do that side first. What? -5? -5. Let's do that again. Let's say -4. Let's do the warm side. Try and get the warm side without doing the cold side. 29. Let's do ambient temperature. 25. This sort of desk. So yes. So that should freeze water. I'm just putting a few drops on here. So the idea here is that the air will go over these fins with a fan. It'll cool the air down, that'll reach the dew point and it will condense on these fins and the water will run down into a draw, partly drawn down by the fan. The air will then blow up past the fins or the big heat sink and cool it down. But as I say, that hasn't worked using this, well, using this fan. And also, well, at a separate time using this fan. So both those fans didn't work at reducing the temperature cool enough. So either wants a bigger heat sink, more fans, or better fans still. I can't see that forming ice, to be honest with you. Let me have a closer look. Now I can't see that forming ice in there. Would have thought it would do. Take a little bit of time, obviously. According by this, that's still on -5 degrees centigrade. I am on centigrade, aren't I? Yes. -5 degrees centigrade. So that's below freezing. And that's on 34 now, the back side. Yes, I can feel this, all this, like this metal tray that's on, getting a bit warm here. I can feel the heat in the warm water. Oh, well, it'd be hard to do this because it's silvery. But let's have a try. So that's suggesting it's 33 there. And the ambient temperature, 24, 25 maybe. Okay, I'll give it a bit longer. This water here, I can feel it's getting pretty warm. Obviously the further away I go, this water could do with circulating, so do we need a liquid cooler, like a computing liquid cooler, whatever it is, CPU cooler, to get this cold enough? It doesn't feel all that warm. It feels ambient temperature, this. Let's put a bit more water in here. Don't want to soak it too much. Just a second. Yeah, that's better probably. Hope that doesn't short out the positive to negative here. 12 volts going in here. I'll leave that water on there and see if it freezes. It should in theory freeze. If that is -5, it should easily freeze that water. I'll come back in about 10 or so minutes, maybe quarter an hour, half an hour. Well, it's been a good quarter of an hour. This is still cold, but it's not freezing the water. I can still see the water in there. This sometimes gets warm. I move this about every so often because it gets warm in the area and the metal. See, that's warm there. That's lukewarm down here. I can feel the warmth there, so I'll move this about to get in a cool area of the water, to try and get cool up. So the idea there is the heat gets, it's like a heat pump, that heat gets sucked, call it sucked, from one side to the other, from the hot side, well, from the hot side to the cold, from the cold side to the hot side. So sucking the heat out of this side and putting it out here in the warm side. Quite a few bubbles on there, so they might insulate it actually, on those fins. I put a bit of water on here to try and keep this cool because it is getting warm even on this side. So let's have a look at the temperatures now. Well, that's saying just 0 is good as. Let's look at the hot side. 43, and the ambient temperature still 25. Let's have another look at that cold side, just under 0. So that should freeze, but it's not freezing. It is cold. Oh, that's quite cold. That's very cold. Oh, I was burning myself with the cold. And this is warm on that side. So it certainly needs the water circulating. Just like all this area here. Well, not all of it, because the heat doesn't transfer that well in water, I don't think. Not without something circulating it. You're shooting away, you're circulating the heat, not the water. You're circulating. So that's not going to work. Yep, that is still water in there. I don't know if I can show you that. I'm trying to move it about because I can't see in the viewfinder. You might see that that is still pretty much liquid. It's just very thin stuff. It's just turning into ice now. When it's very thin water, I can just about see it turn into ice now. I don't think that's because I pulled it out of here. I think it's oops, oh, I wet myself. That's one thing why the fins want to go this way, so that the water will run down. If the fins go that way, then obviously the water is going to be trapped in the blades. But that's not going to work, not like it is. I might try 2 Peltiers, because I do have another Peltier cell, like sandwiched, almost like one on top of each other. I'll see about that. I'm going to look up about that online, see if that's going to be beneficial. That's my ATX making all the noise there. 12 volt off an ATX power supply. Well, putting on 2 Peltier cells, it may help, but if that's going to pump more heat from the cold side into the hot side, you still have to get rid of the heat off the hot side, and that is almost definitely the problem with using this system, well, using this method that I'm using. I think that was, when it was very thin, the water in here, I think it was just about turning into ice, but I can't swear on that. I have had another Peltier crystal cell that did turn to ice without any heat sinks on. I was just testing and playing with it. So stacking 2 Peltier crystal cells on here is pretty pointless unless I get a much better fan, and a much better fan would probably be a lot more noisy, or much bigger heat sink and a fan. So I'll class this as a fail, to be honest with you. But we don't know unless we try, do we? And when I was getting the water off, don't know if you can see it, but I've wet myself.